Okay, so today let's. Oh, by the way, if you haven't checked your grade, go ahead and check your grade. And if you want me, if you want to look at your review your exam, I'm not going to review this week because we still have people and not finished the exam yet. Okay, yeah. So I will bring it next class, and if you want to review, you can go ahead to review it. Okay. All right, so let's take off your notes, and we're going to talk about the new content for the unit 3 parts. That's you. Unit 3. So unit 3 is including 2 parts. The main parts, let's just, okay. So the first part we're going to talk about, that's gonna be called a formula mass. Formula mass. Well, the formula mass is the talk about is the mass for a whole compound. Okay, it's a mass for a compound. Okay, and what exactly is the formula? Let's talk about. Okay, so when we talk about CO2, okay, or sodium chloride, okay, calcium sulfate. Those are what we call the formula. This is the formula that we talk about. This is one kind of the formula, and we call this kind of formula is called a molecular formula. This is a molecular formula. This is a molecular formula, which means this formula shows what is exactly for those kind of compounds. Okay. If there's another kind of formula, we will talk about it later, but this one is called the molecular formula. And there are different kind of the formula. Okay, so this is one kind of molecular formula. Another kind, maybe you see, especially for organic compounds, okay, like for alcohol. Okay, so some people write like this. This is alcohol, okay, this is ethanol, okay. So this kind of structure we call as a structure formula, okay, structural formula, which means it's give you what exactly the formula, how many carbon atoms of there, how many hydrogen atoms there, and also give you what kind of structure of this molecule, okay. So this is called a structure formula. If we have a chance, we will talk about later. Yeah, but so generally formula, that means it's going to be represents what shows in the formula, what shows in the compound, right? This is called formula. Then what is the formula mass? Is generally is talk about what is the mass for this such compound, okay? What is the mass for this such compound, okay? First of all, let's talk about, okay, we already know what is the mass for element. We already know what is the mass for element, like a carbon. If you want to find what is the mass for carbon, just look at the periodic table, right? And then underneath the carbon, it shows is a 12.011 AMU, and then that's gonna be just the mass for the carbon atom, right? That's just a mass for the carbon atom. So what is the formula mass for the formula mass of the CO2, right? The carbon dioxide. And if you want to figure out what is the formula mass, well, then you just need to figure out, okay, how many elements in this formula. For example, in the CO2 in this formula, they have a 1 carbon and plus 2 of the oxygen, right? They have a 1 carbon atom in this formula and plus 2 of the oxygen atoms in this formula. So generally, this formula is composed by 1 atom, 1 carbon, and 2 oxygen. So the mass of this CO2 formula, then that's going to be just 1 carbon plus 2 times of oxygen. And the carbon, the mass for the carbon is just 12.011 AMU. And then oxygen, we already know it shows 15.9994. Okay, so we're gonna time 2 times 15.9994 AMU, and then you add them together. That's gonna be just the formula mass for the CO2. That makes sense, right? Pretty straightforward. Okay, you just need to know how many atoms in this formula, and you add the mass of each of the atom together, then that's mass, that's called the formula mass. Okay, and then you can go ahead, put the number into the calculator. 12.011 plus plus 2 times 15.9994. 44.0098. Okay, 44.0098 AMU. Then this number is exactly what is the formula mass for the CO2. That makes sense? Makes sense, right? Okay, yeah. So this mass is easy, is straightforward. Okay, so what if we have some complicated things like calcium phosphate? Well, calcium phosphate is hard. Remember yourself how to make this. Calcium has 2 positive charge, and a phosphate has a 3 negative. Okay, and 2 and 3. So you know we have a 3 calcium in this formula, and 2 of the phosphate over here. Well, for in this case, then how can we get the formula mass? Again, doing the same thing. You just need to try to figure out what is the atoms in there. And one more thing I need to give you the tip is when you calculate how many phosphate, okay, this 2 over here shows we have a 2 of the phosphate. Okay, so you don't have to count, oh, how many phosphor do we have, how many oxygen do we have. We just need to count how many total phosphate do we have. Okay, so this one is more easily to figure out. Okay, you just need to figure out, okay, what is the mass for the phosphate, and then you time 2, then you give the total mass on the phosphate part. Are you clear? Okay, so now what do we do for when you calculate the mass? You have 3 of the calcium, right? We have 3 of the calcium. This one shows we have 3 of the calcium, and the plus 2 times the phosphate. Okay, so this mass is what is phosphate inside. Okay, you don't have to count how many phosphor do we have, how many oxygen. Well, you can do that way, but this one is more easily or straightforward because here the 2 means we have 2 of the phosphate. Okay, so what's inside, you just need to calculate what is the mass of the phosphate. That phosphate is made by 1 phosphor and 4 of the oxygen. Okay, so this is oxygen. All right, then you just plug, then you're going to plug the average atomic mass in there, then you will figure out. Okay, so now calcium is 40.078, AMU, and plus 2 times phosphor. Phosphor is a 30.97, 30.9737 AMU, and plus 4 times oxygen, 15.9994 AMU. Okay, yeah. So now you see what's inside. That's gonna be the mass of the phosphate. Okay, then you time 2. That means we have 2 of the phosphate, and plus the mass for the 3 of the calcium. You add them together. That's gonna be the former mass for the calcium phosphate. Okay, yeah. So now let's put it into the calculator. 3 times 40.078 and plus 2 times parenthesis 30.9737 plus 4 times 15.9994. 310.1766. AMU. Then that's gonna be the former mass for the calcium phosphate. Okay, yeah. Okay, so now go ahead. Now it's your turn to make the practice. Okay, yeah. So what is the formula for the calcium copper sulfate? Okay, go ahead to figure out what is the molar mass. What is the mass, former mass for the copper sulfate? And what is the mass, former mass for the iron hydroxide? Okay, so let's look at it. So if you look at the copper sulfate, copper 2 sulfate, we have one copper. So we're going to write down what is the mass for the copper, and one sulfur, just write the sulfur's mass, and 4 of the oxygen. So the oxygen atoms times 4. So this is the total composition of that. Then you add them together. That give you the mass for the copper sulfate. Okay, so 63.546 plus 32.066 plus 15.9994 times 4. And 159.6096. Okay, 159.6096. So that's gonna be the former mass for the copper 2 sulfate. Iron hydroxide doing the same thing. Okay, yeah, this number is the mass for the iron. And here we have 3 of the hydroxide. So you just have a 3 times what's the mass inside. 1 oxygen plus 1 hydrogen. Okay, so now $55.847 plus 3 times parenthesis 15.9994 plus 1.00795. And you got this number. Well, the molar mass on here, sorry, not the molar mass, the mass, the atomic mass on this periodic table may be different from the one that shows on your periodic table. That's okay. That's okay. A little bit difference. That's fine. Okay. Yeah. Just because they have a different rounding. So if you have do not have exactly the same number, that's okay. As long as that's probably is just because we don't have the exactly number shows over here for each of the atoms. Okay, that's totally fine. Okay, a little bit different. That's fine. So I got a 106.86905. Okay, so this is give you the molar mass. Oh, sorry, this is give you the formula mass for each of this compound. Okay, now it's easy, right? Yeah. So the next part is getting harder, and this is the very, very fundamental concept in chemistry, is mole. It's a mole. Okay. Maybe some of you already heard of what is a mole. What is a mole? Anyone heard of this concept before?
It's like 4 elements, and instead of like a bushel, it's like mole for like it's a thing of measurement. Like,
To be honest, the mole concept, I mean, when I first learned this, it's confused me a lot. Okay. I'm not quite sure about what exactly the mole is. Okay, mole is the unit, but the mole is a unit for a certain number. It's a unit for a certain number. Okay, that is a mole. Okay, so what does that mean? So let's give you some of the similar concept. Like when we talk about, we can talk about the pair. Dozen. Okay, so what do you think about a pair and a dozen? Is a unit or is a number? Is a number, right? So one pair give your talk about is two thing, 2, right? One pair is a 2. 1 dozen is a 12. Okay, yeah. So the pair and the dozen, actually it means some numbers. A mole is also the same thing. Okay, it's also talking about a certain number, but this mole number is really, really big. Okay, it's really, really big. That's it. Okay, so when we talk about one pair and we know we have 2 things, And two atoms, that's a pair of atoms, right? And we have if we have a 12, a dozen of this, we know we have a 12 of those atoms, okay? But if we talk about a mole of the number, and this is not just a 2, not just a 12, it's a huge number. It's a lot of the numbers of the atom aggregate together, and this is a mole, a very, very big, large number. And this group of those number of the atoms, we call it a 1 mole of this. Okay, so the mole is a very, very big number. How big this number is a 6.02 times 10 to the 23rd. Okay, so this is a really big number, and we call this number is called the Avogadro's number. Avogadro's number. Okay, so this number is a really, really big number. But when people see 1 mole, it generally talk about we have a 6.02 times 10 to the 23rd of those numbers of the molecules or atoms aggregate together, and this is called 1 mole. Okay, yeah, it's not a 1 pair, it's not a 1 dozen, but it's a 1 mole of that much of the numbers. Okay, we will talk about, okay, why we choose this number. Okay, they have some very benefit. But first, you probably have no idea what is the 6.02 times 10 to the 23rd mean. I have no idea when I first learned this. I just think, okay, this is just a number. Okay, you can think about it. Okay, so this is a 6.02, and there are 6. So generally, you write 6, and you're gonna write the 23rd of the zeros after the 6. This is a really, really big numbers. Okay, yeah. We talk about the trillion. Trillion is 10 to the 12. Okay, so this one is trillion of trillion. Okay, so generally is about this number. Okay, but let's just give you another comparison. Okay, so let's just do one of the examples. Anyone? So you generally know what is the size of what is the mass of the lollipop, right? Lollipop is generally this big, right? Usually it's about like 5 grams for the lollipop. Okay, so what do you think if we have 1 mole of the lollipop? 1 mole of the lollipop aggregate together. What is the mass of that? You don't have to do the calculation. Just want you to think about, okay, how heavy this 1 mole of the lollipop it could be. Okay, it's like as heavy as a tank, as heavy as like a cruiser, as heavy as like an elephant, whale, or something else. Okay, what do you think? Just to give your an idea, what is the 6.02 times 10 to the 23rd? We have a mole of the lollipop aggregate together. What do you think? Think big. That's a really big number. Yeah.
Well,
Okay, a mass of whale. Okay, Daniel. Give me a guess. Not sure. Roof.
like a ship.
Ship. How big the ship is? Titanic. Bigger. It's bigger. Okay, right.
Like half the Earth, I don't know.
Half the Earth. It's close. Okay, it's close, but it's smaller than half of the Earth. Okay, I did a rough calculation. It's about one tenth of the Earth, the mass of the Earth. So you can think about what is a mole mean? 6.02 times 10 to the 23rd. This number is really big. Okay, a mole of lollipop is about like 1/10 of the Earth. Okay. Another imagination, okay? The donut is about the thickness of this, right? Yeah. So if we have a 1 mole of donuts stacked together, do you know how long it will be?
Go into space.
Huh?
Go into space.
Yeah, it will go into space, but how long do you think? It's about from Earth to the sun and come back. Okay. So that's the distance if you have a 1 mole of that. Okay, so remember 1 mole is the aggregate 6.02 times 10 to the 23rd numbers of that stuff grouped together. That is called 1 mole. Okay, yeah. So obviously the mole, this group number is not useful for the normal stuff that we can see, but it is very good the number group for atoms, for ions, for molecules. Okay, because those guys is very small, tiny. Yeah. So if you have a 1 mole of those stuff together, and then the mass of those, doesn't matter what kind of elements, then it will make sense to us. It will make sense to us. So that is why people, especially in chemistry, were using 1 mole of that. Okay, because a pair of atoms, the mass of a pair of atom is still very, very small. Okay, you cannot using your balance to measure a pair of the oxygen gas. Okay, or a pair of the copper sulfate. Doesn't matter what kind of compound. A pair of those molecules, you never be weighed. Okay, you cannot do a dozen. It's still very small. Okay, but if you weigh a mole of that, okay, you definitely can using your balance to measure a mole of those stuff. Okay, yeah. So this is why we're using this. And another beauty for the mole is, well, when you're using a mole of this, and you don't have to changing the, you still can find the numbers. Okay. Last time we talked about this number, 63.546 AMU. AMU is the mass for the copper, right? But if we have 1 mole of copper together, it is still, so if we have 1 mole of the copper, they are still going to weight like 63.546. But the unit is not going to become AMU. It's not AMU. Instead, they're going to become a gram. Okay, so that is the beauty of using 1 mole. Okay, yeah. So the people, this number is people define. They figure out. Okay, you don't have to understand why the people using the 6.02 times 10 to the 23rd, this number, but you can just you can use this number, because if we have 1 mole of copper, we're going to have a 63.546 gram. Okay, instead of 1 molecule, 6. Let me just write down over here. So for the copper, if we have 1 molecule or 1 copper atom, that's a 63.546 AMU. But if you have 1 mole of the copper, 1 mole of the copper, which means you have a 6.02 times 10 to 23rd of the copper atoms aggregate together, the mass of those atoms together will be 63.546 gram. Okay, yeah. So that is the number is exactly the same. The only difference is just changing the unit. Okay. Are you clear? Okay, so that is why we're using mole, this concept, because once you have that much of those numbers, atoms together, you can measure it. You can using your balance to measure it in the lab. Okay, so let's take a break and we will talk more. Okay, so let's come back. Okay, so now we're talking about is the, okay, if we have a 1 mole of those molecule, what is the mass for this molecule? 1 mole of this, what is the mass? Okay, so generally we're doing the same thing. If we have a 1 mole of the oxygen atoms, you can again just look at your periodic table, you can find that should be a 15.9994 gram. If we have a 1 mole of the hydrogen atoms, well, that's going to be, I just write atoms, okay, atoms. And then that's going to be just 1.00795 gram. Okay, yeah. So generally it's the same thing. 1 mole, if you have 1 mole of that, then again, the number is the same. The only difference is changing the unit. That's it. 1 atom, if we have 1 oxygen atom, is a 15.9994 AMU. AMU is also a mass unit. It's one kind of mass unit. But if we have 1 mole of that, it's going to be a 15.9994 gram, which means you can, the unit is in gram, so you can measure the mass, okay, in your balance, okay, with your balance. All right. And we're doing the same thing for the molar for the molar mass, right? And last time we already figured out what. So for one, if we have a one CO2 molecule, what is the molar mass for the one CO2 molecule? We did that in the previous parts. It's equal to 44. Anyone can help me to 44.098 AMU, right? And then the same thing for 1 mole of the CO2 molecules. It's not one molecule. This is 1 mole of the CO2 molecules. Then that's gonna be 44.098 gram. 98 gram. Okay, yeah. So generally it's the same thing. And 1 mole of the CO2 molecules, and we talk about 1 mole, it generally is just equal to 6.02 times 10 to the 23rd. If we have a 6.02 times 10 to the 23rd of the CO2 molecules, they get together and we weigh the mass of those molecules is equal to 44.098 gram. That makes sense now? Okay, yeah. So mole is a number, but if we add those numbers together, we can find a certain number for the molecules or atoms. And those numbers we can find in the periodic table. That is why we're using mole concept over here. Okay, yeah, that's why we're going to use more concept. All right, so now generally you see mole, we're using mole over here, but the mole actually connecting to two things. First of all, mole is connecting with molecule numbers. Molecule numbers, right? So 1 mole is equal to 6.02 times 10 to the 23rd. Okay, but so if we talk about if we have 2 moles of the molecule, how many numbers of molecules in there? Then just 2 moles of molecule. 2 moles of molecule is how many molecule? It's 2 times 6.02 times 10 to the 23rd. Okay, so generally we can converting the moles of the molecules to how many number of the molecules. That makes sense, right? Okay. Another thing is mole can also convert to the mass, especially in gram. The mass in gram, because we know we can find 1 mole of the certain things equal to how many moles of the how many gram of these atoms. Okay, we can find it in the periodic table. Okay, yeah, in the periodic table. So that part is the very important part, and this is a fundamental part for the following calculation, following topic in chemistry in this unit too. Okay, yeah, we're going to do the conversion between mass and mole to the molecule number. Okay, mass and mole to the molecule numbers. Okay, yeah. Before we talk about this, we are going to talk about one more concept, and this concept we already talked about over here. This is called the molar mass. Molar mass. Actually, it already shows over here. Molar mass, they are another name is called the mass per mole. Mass per mole. Do you know what is a per mole mean? Per mole, that means per 1 mole, which means mass per mole, that means in 1 mole of certain stuff equal to how many mass. Okay, that's it. So generally, molar mass is just talking about is the mass of the certain subject of 1 mole of this subject, how many mass for 1 mole of the subject? Substance. Okay, how many mass of 1 mole of the substance? Okay, for example, we wrote over here 1 mole of the hydrogen atom is equal to 1.00795 gram. So the molar mass, so we can rewrite this statement. This top statement is the molar mass of hydrogen atom equal to 1.00795, and the unit is changing, is in gram per mole. Okay, gram per mole. So generally gram per mole, the slash here has a meaning. The slash actually means division. It's a gram divided by mole, and this is the unit. Those two units is same. Okay, the slash actually is just a division line. Okay, so and this unit is called the gram per 1 mole, which means 1 mole of this substance, 1 mole of the hydrogen atom is 1.00795 gram. Okay, yeah, so that means gram per mole. And generally, all the numbers shows on the periodic table, those are all we call the molar mass. Okay, so for example, if we talk about the sodium, 22.98977, and that is the molar mass of the sodium, which means 1 mole of the sodium atom is 22.98977 gram. Or you can just write molar mass of the sodium is equal to 22.98977 gram per mole. Okay, yeah. So molar mass, the unit is a gram per mole. Okay, again, molar mass unit is gram per mole. It's not in gram. It's not in gram. It's a 1 mole of this is what? Okay, so that's a gram per mole. So the molar mass. So in the future, I'm going to just write those 2 mm. Okay, the molar mass of the oxygen atom. Then you can write the molar mass of the oxygen atom. You look at the oxygen atom, that's a 15.9994, and this is in gram per mole. Okay, gram per mole. Okay, yeah, and again, the same thing. If you want to write the molar mass of a compound, right? The molar mass of a compound is doing the same thing for the CO2, okay, gases. Okay, and the molar mass of the CO2 gases, again, that's going to be 44.09. We just did that. It's a 44.098 gram per mole. Gram per mole. So that is just a concept for the molar mass. Okay, yeah, molar mass. This unit is a combined unit with gram or mole. So that is why if you look at the molar mass, generally the equation you can figure out the molar mass actually is coming from the mass or the gram of the substance divided by the mole of the substance. Okay, so if you know the gram of the certain substance, you divide by how many mole of the substance in the of this, then you will figure out what is the molar mass. Okay, yeah. So generally, this is the concept for the molar mass. This is a concept for the molar mass. This is a concept for the molar mass. And this is also the conversion between mass and mole. This is also a conversion between mass and mole, because molar mass shows over here, and we have a mass and we have a mole. Air conditioner, right? Okay. Okay, so now let's look at the conversion between mass and mole. Let's look at the conversion between mass and mole. So if you look at this equation, very important, the equation here, molar mass equal to mass over mole, not the mole over mass. Gotta remember, okay, molar mass is called a mass over mole. That is the, so if you want to figure out the mass, if you want to figure out mass, which is on the top part, mass should be equal to molar mass multiply mole, okay? Mass should be equal to the mole time molar mass. Okay, mass equal to mole time molar mass. I know you can write this in your note or in your the cheat sheet for the exam, but I strongly recommend, okay, to remember this. Okay, I always remember this. Mass equal to mole time molar mass. And then if you want to figure out the mole, then mole should a lot of things. Okay, mole is not equal to molar mass times mass. Mole should be equal to mass over molar mass. Okay, mole should be equal to mass over molar mass. Okay, so those are two different things. Mass equal to mole time molar mass, and mole equal to mass over molar mass. Okay, two equation. There's two equation, very, very important. I strongly recommend you're gonna remember it. Okay, mass equal to mole time molar mass, and mole equal to mass over molar mass. Okay, give you one of the example. Okay, so for example, I'm measuring 30.0 gram of the sodium chloride. I'm measuring 30.0 gram of the sodium chloride. The question is, how many moles of the sodium chloride do we measure? Okay, I know I measure 30.0 gram of sodium chloride, but how many of the mole of the sodium chloride do we measure? Okay, so generally we're trying to convert the mass of the sodium chloride to the moles of sodium chloride. Before we're doing this work, first of all, you need to find what is the molar mass of the sodium chloride, right? You have to know what is the molar mass. The first step is you need to know what is the molar mass of the sodium chloride. And how to find the molar mass of sodium chloride? You're gonna look at your periodic table. Sodium chloride is made by one sodium atom and one chloride atom. So you just need to write the sodium plus chloride, and you can figure out what is the molar mass for each of those atoms. Sodium, that's a 22.98977. And plus the chloride. That's chlorine 35.453. Okay, then you add them together. This gives you the molar mass of the sodium chloride. 22.98977 plus 35.453. You got 58.44277. 30, no, 58.4444277. And that is the unit. Again, the molar mass of the unit. What is unit again for molar mass? Gram per mole. Okay, that is gram per mole. That is the molar mass of a unit, gram per mole. Okay, yeah. So that means 1 mole of the sodium chloride should have that much gram. Okay. Now, how do we convert the mass to the molar mass? Again, based on this equation, how to convert the mole mass to the mole. Okay, mole of the sodium chloride should be equal to the mass of the sodium chloride, which is we have a 30.0 gram. 30.0 gram of the sodium chloride. This is what we have, and divided by the molar mass of the sodium chloride. Again, the mass of those sodium chloride can be changed. That really depends on what the question gave. But the molar mass is never be changed because the molar mass is what you get from the periodic table. This molar mass number is always fixed. Okay, molar mass for a certain chemicals, the molar mass of these chemicals is never be changed. Okay, but the mass will be changed. That really depends on what the number gave to you. Okay, the number gave you 30.0 gram. That's the mass. It will be 30.0 gram. If it gave you the other numbers, then they give you, then that's going to be the different number. Okay, so divided by 58.44277 gram per mole, the unit. And if you look at the unit over here, you see gram on the top, this gram on the bottom, so the gram and gram can be canceled. Mole flipped up, actually, it just gives you a mole number. Okay, so if you look at the unit, you will also figure out, okay, when you're doing this calculation, it will give you the mole. Okay, so now 30.0 divided by 58.44277, and give you this number 0.51332. 0.51332, and this unit is in mole. Okay, in mole. Well, then that's give you a mole number, but we haven't done yet because we need to look at the sig fig. Do you know how many sig fig for this question? 3. Okay, why? This question only give you one number, 30.0 gram. Okay, 30.0 is a 3 sig fig. So that is why we have a 3 sig fig. You may ask, you may say, okay, we have another number right here for the molar mass. And again, just to let you know, molar mass, the number of the molar mass never be used involved in the sig fig. Never count for the sig fig. Okay, yeah, doesn't matter the molar mass is a big number or small number, they are not used for the sig fig calculation. Okay, yeah, so the sig fig only looking at the how many the sig fig, that's the question gave to you. Okay, the question gave to you. So 30.0 gram. 30.0 gram. Okay, 30.0 gram. Then we have a 3 sig fig. Now we have 3 sig fig. So count 1, 2, 3. So the answer will be 0.513 mole. Okay, 3.3513 mole. And that is the molar mass of the sig fig. Sorry, that's going to be the mole of the sodium chloride for 30.0 gram. Okay, yeah, for the 30.0 gram. Any questions? Pretty straightforward, right? Okay. Okay, then let's do some of the practice. Okay, so let's do one of the practice. So go ahead to work on the first question. Okay. First, let's work on the second question. Okay. How many moles are 98.3 grams of the aluminum hydroxide? Okay. So first of all, what do? You're gonna figure out what is the molar mass of the aluminum hydroxide, and use the equation I gave to you, gram to convert to mole, which is mole equal to mass over molar mass. Go ahead. Here, this is the answer key. So if you figure out the answer, then you can check whether you got it right or not. Okay, so let's review this question. So first of all, if you want to convert between mole and mass, doesn't matter from mole to the mass or mass to the mole. The first thing you need to do is try to figure out the molar mass of this compound. Okay, yeah. For the aluminum hydroxide, their molar mass is just aluminum, one of the aluminum, and times 3 of the hydroxide. So 3 times the hydrogen plus oxygen together, and we got the molar mass. This is the first step. If you got a wrong molar mass, then you're gonna have all the calculation wrong in the future, in the rest of this. Okay, so 78.00359 is the molar mass of the aluminum hydroxide. And then you try to figure out the mole. So again, mole should be equal to the mass over molar mass. Okay, mass over molar mass. So mass, we have 98.3 gram, and molar mass is 78.00359 gram per mole. Okay, and then just put that into the calculator, 98.3 and divided by 78.00359, and you got 1.244. Okay, so 1.244, that's a mole. And then if we want to do the keep the sig fig, this is 3 sig fig. So we suppose keep 1.24. Okay, 1.24 more. A little bit difference this. Okay, so this answer should be 1.24 more. Okay, yeah. The reason is different. It's probably is because the molar mass you choose. Okay, if you choose a different number of molar mass, it will change a little bit. Okay, it will change a little bit. Okay, yeah. Well, any questions? Anyone got 1.26? You got 1.26. So what make your difference?
I just use the numbers from here.
Okay.
I had 78.0035586.
That's pretty similar, right? Okay, let me do one more time. Oh yeah, my mistake. Okay, that should be 98.3 divided by 78. I typed 79.00359. Okay, 1.26. Okay, so that makes sense. Okay, that should be 1.260. We got a 1.2602. And then we keep 2 sig fig, it should be 1.26 mole. Right? Okay. So now this is give you the mole. Okay, give you the mole. The next part, okay, so we got, okay, mole should be equal to mass over molar mass. Then how do we got the mass? Okay, from mole. If we have a mole, how do we got a mass? Again, the equation is mass should be equal to mole time molar mass. Okay, so mole time molar mass, then give you a mass. Mole time molar mass, they give you the mass. So now, again, before you're doing this, you have to figure out what is the molar mass for the sodium fluoride. Sodium is a 22.98977. Plus a fluorine, which is 18.998403. Wow, that's pretty big. Okay, so now 22.98977 plus 41.988. 173. This is gram per mole, the unit. That's the molar mass of the sodium fluoride. Again, based on this equation, the mass should be equal to mole times molar mass. We have a 4.50 mole of this sodium fluoride. You're gonna time molar mass of the sodium fluoride. So 41.988173. And this time together will give you the molar mass. Four 0.50 times 41.988173. So 188.946. 188. 947. And this is in gram because it's a mass, right? So if you look at the unit, this is a unit is a mole, and this unit is gram per mole. You see, mole, this mole in the bottom part, this mole in on top. So this mole and this mole canceled. The leftover unit is a mass. So mole times molar mass should give you the mass, okay, which is in gram. And this is the mass. And again, the question gives you 3 sig figs. So you should keep 3 sig figs, 1, 2, 3, and look at the next one. So that's why the answer should be 189 gram. Okay, so that is the answer. Okay, yeah. So this is give you the conversion. The first, and generally we're done for today. Okay. We're just doing the conversion between mass and mole. And the next class, we're doing the conversion between another set of the conversions. Okay, yeah. So today we're done for here. Next class, we do not have a lab. Instead, we're doing a practice. The practice for the unit for the conversion between mole and the mass and molecule numbers Okay, so let's go to the lab, and I need 2 volunteers help me to bring the key, the lab kit to the lab.